The question says find all possible values of alpha for which the curves y equal to alpha x square plus alpha x plus 1 by 24 and x equal to alpha y square plus alpha y plus 1 by 24 are tangent to each other. Now from the construction of the function, we can easily see that the position of x and y in these two curve equation have been just interchanged, and that literally means that the two parabolic function or the graphs, they are basically inverse of each other, or they will be basically mirror image of each other about y equal to x graphically. So in the figure, this is the line y equal to x which is acting as a mirror, and this is the graph of y equal to, this one is the graph of y equal to alpha x square plus alpha x plus 1 by 24, and this one is the mirror image of the graph having the other equation. So three possible cases actually may arise. The first case is that the first graph, it doesn't intersect the mirror line y equal to x. So if it doesn't intersect the mirror line y equal to x, automatically its mirror image will not also intersect the line y equal to x. So the two graphs will be separated from each other. So since they will not intersect, so in this case there is no tangent possible to each of them. So first case is an impossible case. So in the first case they cannot have a tangent to each other, common tangent to each other. Second case is that when both the graph will simultaneously touch the mirror line, that is y equal to x. As the two graphs, they are mirror image of each other, so we can easily say that they can touch this particular mirror line y equal to x, and then y equal to x itself will become the tangent to both the graph, and we can easily say that the graphs are touching each other. So in this particular case we can say that this line y equal to x is acting as the tangent to the first function as well as the second function. So for the first function, that is y equal to alpha x square plus alpha x plus 1 by 24, if we see the slope of the tangent to the graph, that is dy dx, so dy dx will come out to be 2 alpha x plus alpha. Now in this particular case, that slope of the tangent must be equal to 1, because we know that y equal to x is the tangent. So the slope of the tangent is equal to 1, and from here we can see that the value of x at which the slope of the tangent will be 1 comes out to be 1 minus alpha by 2 alpha. And now we can say that this particular point can also be obtained by solving y equal to x with the function itself, that is alpha x square plus alpha x plus 1 by 24. So we can easily see that by solving this particular equation we should get the same root by equating the slope of the tangent to be equal to 1. So on solving this equation we are getting x into 1 minus alpha equal to alpha x square plus 1 by 24. So here substituting the value of x previously obtained, we'll be getting 1 minus alpha square upon 2 alpha is equal to alpha into 1 minus alpha square divided by 4 alpha square plus 1 by 24. So on simplifying we are getting an equation (1 minus alpha square by 4 alpha), that is equal to 1 by 24. So on opening up we are getting a quadratic equation, that is 6 alpha square minus 13 alpha plus 6 equal to 0. And on solving this equation we can easily say that it will be having two factors. So these are the two factors, 3 alpha minus 2 and 2 alpha minus 3. So we can say that the values of alpha will come out to be 2 by 3 and 3 by 2. So these two are possible values of alpha for which the second case will be imposed. That is, both the graph will be touching each other and that tangent is going to be the mirror line y equal to x. And there can be another possibility, that is case number 3. We can have a case 3 where actually you can see that the tangent to the first graph will be a line which is perpendicular to y equal to x. So we can say that the tangent line is making an angle 90 degree with y equal to x. So this is the mirror line y equal to x. And if the tangent makes an angle 90 degree with y equal to x, then we can also say that for the mirror image graph, this tangent will again be touching the other graph due to the symmetry. So again in this case the two parabolic graph will be touching each other at this particular common point. And as you know that this particular tangent is perpendicular to y equal to x, so this particular tangent will be having a slope that is -1. So in this case the value of dy dx that was previously obtained to be 2 alpha x plus alpha, that will be equal to -1. So in this case the corresponding value of x will come out to be -1 minus alpha divided by 2 alpha. So again, on solving y equal to x and the parabolic function alpha x squared plus alpha x plus 1 by 24, on solving the two equation in this particular case we'll be getting the point of intersection, and so we can say that the corresponding value of x -1 minus alpha by 2 alpha will also satisfy this equation. So again, solving the value of x like the previous case, let us substitute the value of x here in terms of alpha. So it will become minus of 1 plus alpha into 1 minus alpha by 2 alpha is equal to alpha into 1 plus alpha square divided by 4 alpha square plus 1 by 24. So let's try to find out the value of alpha from here. So this is giving us alpha square minus 1 by 2 alpha is equal to 1 plus alpha whole square divided by 4 alpha plus 1 by 24. So let's try to simplify this equation further. So we are getting a quadratic equation 6 alpha square minus 13 alpha minus 18 equal to 0, and this will give us other possible values of alpha. So that will be alpha equal to, using the Sridharacharya principle, so from here we are getting other values of alpha to be 13 plus minus root over 601, sorry, divided by 12. So these are other two possible values of alpha. So the final answer will be alpha equal to 2 by 3 and 3 by 2, as well as these two irrational values.